Good morning, good afternoon, and good evening. Welcome to the June edition of Power BI Dev Camp. Today we're going to be doing a session on developing for Power BI using Azure Functions. With us, as always, is our Dev Camp counselor, Ted Pattison from the Power BI Customer Advisory Team. Ted, how are you doing?
Thanks, Daniel. I'm doing just great. Very excited about our session today. Been bulking up on Azure Function knowledge to give this session over the last month. So
That's great.
good news.
That's good to hear it. I will pass the marshmallow sticks and everything for the Dev Camp over to you, and on with the show.
Thank you for warming up our campers here. Hope everyone's doing well. Those who are attending live, those who are watching the recording. So just a quick word, shout out to Power BI Dev Camp. We have a portal, and one of the best things about the portal is if you go there, after one of our sessions, you can find the page for that session and find the links to the things that we're going to show you. One of the links is going to be to a GitHub repository, where all the demo code is that I'm going to be showing. The idea is if you like the project that I demo, you should be able to take it, stand it up, and kind of get it running yourself. Also, if you want the PowerPoint slides, that I'm going to be showing, those are freely available as well. Okay, so let's go ahead and move back to the slides here. And so what we now want to look at is the agenda for today. So we're going to start just with a quick primer on Azure Functions. And, this is not a session where we're going to deep dive into Azure Functions. So what I'm thinking is many people here have a background with Power BI development. Hopefully some of you have already used the Power BI REST API, and maybe you've been running things in console applications or in PowerShell scripts. Now you're kind of looking for a centralized way to do tasks in Power BI. So we're going to jump in and do a primer and just kind of learn the fundamentals. We'll quickly work towards creating Azure Functions that call the Power BI REST API. And then we're going to look at some interesting solutions that is going to involve writing data files into Azure Storage. And then also we're going to have a demo where we have an Azure Storage container, and whenever someone uploads a CSV file, we're going to have a trigger run code that takes the file and basically builds a data set, points to that file. And so it just kind of automates wrapping a data set in a report around a CSV file, and the application automatically responds to files being uploaded. At the very end, we're going to show a quick example of a single page application created using React, that is basically the consumer and can call these Azure functions. Okay, so let's kind of start with some Azure Function, the essential concepts and the fundamentals. So the idea is that Azure Functions give you a simple way to write code and not have to worry about having servers or having Azure web apps as some place where you have to deploy your code and manage either the server or some type of 24/7 service instance. So it introduces this idea of serverless, where if you only make 10 calls a month, you don't pay for all the time in between. You're kind of just paying for the execution. Now, of course, Azure Functions don't force you into serverless. You can get Azure Functions on top of a Azure service plan, that basically has some premium features, being able to run longer without timing out, being able to have hot starts instead of cold starts. But one of the nice things about Azure Functions is you don't care so much about how they're deployed and how they're hosted. It just kind of works. Now, with an Azure function, think of it as you write code, and then there's going to be some configuration. And the more we can do with configuration, the less code we have to write. So when you define Azure Functions, the concept of a trigger and a binding is really important. A trigger is what provides the mechanism to start the function with its execution. Function bindings, as you'll see, provide a nice configurable way, to get to a resource like a blob file in Azure Storage. It just kind of makes your code a lot more seamless to write, and also makes it much easier to update if you only have to update the configuration but not the code itself. Now, when you decide to create Azure Functions, you have quite a few choices. So they allow you to choose between C#, Java, JavaScript, PowerShell, F#, and Python. Developers can also use the Visual Studio 2022. That's what I'm going to be using. If you like using Visual Studio Code, I'm a boomer, so of course I use Visual Studio, being old school. And somewhat arbitrary decision in this session, I'm going to be demonstrating C# and basically using Visual Studio 2022. So if you wanted to use a different language and/or Visual Studio Code, the steps would be different, but you can get the exact same effect. And once again, this is not a deep dive into Azure Function development. So if you've been developing with Azure Functions, for a year and you're looking for some advanced binding concept, here we're just really going to cover the fundamentals and immediately see, how we can, create useful solutions, for Power BI. Okay. Now in this demo, there's going to be, basically 3 Azure resources. If I go back here and I go ahead and, let's say that I go back into the Azure portal and go to this resource group, Azure Function demos, and I open it up, what we can see here, now I'll just kind of go back to the slides, is that there's 3 main things that, you'll need an Azure subscription to create. So the first one is the Function app. When you create the Function app, it's going to create a service plan, or you can connect it to it. But the service plan kind of serves as the underlying plumbing for the Function app. There's going to be a Key Vault, and the idea is I might have secrets, and I don't want to put them into configuration files. I want a secure way where we can make updates and have my code, but no one but the code be able to kind of see what those secrets are. And then also we're going to use an Azure storage account. So once again, to get this demo working, the demos I'm going to do today, you can see there's an Azure Key Vault, there's an Azure Function app. If I go ahead and open up, this Function app right here, here is the configurable page that you can start working with the Function app. Now, when we develop Function apps, you basically, when you develop Azure Functions, you do it in terms of a Function app. So a Function app is, first of all, kind of the creatable unit in Azure. You don't create just an Azure function, you create an Azure Function app, and that's a container in which you can add your functions. From a development perspective, the Function app is also the scope at which we create a project in Visual Studio Code or Visual Studio. Now, when you build a project, you basically have to commit to a language. It used to be you could use multiple languages, but a couple versions back, they decided they could do things much more reliably, if every Function app, was based on C# or Java, or the Node.js environment for running JavaScript. Now, what we're going to do is we're going to create this project, and then we're going to start generating these classes. And each Azure function gets put in a separate class. And once again, these details are very specific for the way C# works when you use Visual Studio or Visual Studio Code. If you were using Java or PowerShell, things would be completely different. But the idea is that every time you create an Azure function, it will create a new class, and that class will have a run method. Okay, now you'll also see that, inside of the run method, we can define triggers. Now, if I kind of take a look, at the screen up here, one of the things that I can see is that there is an HTTP trigger right here. And notice that this is the first parameter. And the idea is that when you use C#, you get to define parameters, put attributes on them to define your triggers. And as we'll see in the next slide, the bindings as well. Look down here, and here is a timer trigger. The first one, the HTTP trigger, allows you to kind of create an endpoint that you can, execute it just by making an HTTP request. The timer trigger runs at a schedule. One of the things I'm going to circle right here, is this language, which is, you create cron expressions. This is something, if you want to get into it, there's plenty of documentation, but this basically says, run once a day at 6 a.m. One other little fun fact is that when you create these timer triggers, typically you say run on startup equals false. However, if it runs once a day, how are you going to debug it? You're not going to start the debugger and wait for 12 hours for that to occur. Instead you say run on startup equal true, and it just kind of gives you a way to execute, as you're doing your debugging, in Visual Studio or Visual Studio Code. The last trigger here we're going to look at, is the blob trigger. And the idea of the blob trigger is that every time a file gets uploaded to Azure Storage in a container that we're monitoring, all of a sudden this code's going to run. And the idea is every time a file gets uploaded, I can have a piece of code that responds to do some processing based on that. And so I would say these are the three basic trigger types. One which is a HTTP endpoint, one which is a scheduled process, and then this one, the blob trigger, which is one of many different integrations with Azure services. We're going to just look at blob triggers in Azure Storage, but Azure Storage has tables, queues. Once again, we're not going to get into those details here, but there's a lot more. But this is kind of an event trigger that responds to, something being added. In this case, a file being added to an Azure Storage container. Now, we've just looked at triggers. The run method is always going to have the trigger as the first parameter, and sometimes the first two parameters. However, what you can see here is after the blob trigger, we have this second parameter. And the idea of this binding is that I can point to a file name. And I can say, here is a PBIX template file. I don't want to have to write the code, to reach into storage and find the file and pull the bits back. I just want to configure that, declaratively. And whenever this function runs, it just passes me. You can see it's a stream object, to this particular file. So that's where reading with a binding. Well, we can go the other way as well. So here is a binding that has file access.write. So this allows me to, if I have a timer trigger that runs once a day, what I want this function to be able to do, is to either create or override a file in a storage container called PBI data, and the file is named workspaces.json. So there's some really neat things as far as simplifying how you write your code. One last thing to note is that each language you use to create your Azure functions are going to be different. Your experience creating it with PowerShell would be much different. What's really neat about C# is you get to work with these attributes. Now, one of the things that has to happen behind the scenes is that the code in your Azure function has to be complemented by a function.json file. And so what's kind of neat about the C# approach is that they can use reflection, automatically read through your code, and automatically create these function.json files, that have to be packaged and deployed along with your function. Okay, just going a little bit further here. Let's say that we want to create a new Azure Function app in the Azure portal. Here's kind of the screen that you're going to get. Some things to call out is that the function app has a name. Mine is called Dev Camp Demos, and it's automatically accessible, if you use the HTTP trigger, through https://devcampdemos.azurewebsites.net. Now, you can also see with this one, I based it on .NET 6. I get to decide what data center, US East 2, what region it runs out of. And I can pick a plan. Here I picked the cheapest one, the consumption plan, which is serverless. And I can also pick one of the plans that's more expensive, but doesn't load things out of memory and kind of have a startup cost. Okay. Now, we're going to create projects. And these projects are going to be just like a console application that you create in Visual Studio, and the fact that you can just open up the NuGet Package Manager and start adding packages. So for the demos that I'm going to be doing, here are the different packages that get added in. Now, also note that, let me break and do one quick demo. Let's say that I want to create a new project. So I'll create a new project, and I'm going to pick Azure Functions, as the project type. And so we'll call this something like Ted's Function App Starter. And as you create this, it's going to ask me one more question. And the idea is that now what I'm able to do is to add new Azure function. Now, this isn't required, but it's kind of a habit, and the demo code that I wrote, is going to create a folder, which is called functions. And now that we've done that, let's go back here and say add, and we're going to add a new function. And so when you add a new function, let's call this one, get me beer. And when I create this, it has to know what trigger I want to use. So we're just going to use the simplest one, the HTTP trigger. For now, we'll just keep it anonymous, and we'll go ahead and choose add. And so now we have this kind of starter. So, now you've kind of seen the starter here. Let me kind of go through and kind of clean some things up. What are the kind of things that we might need? There's the run method. Do I want to support get and post? I don't want to support post. I just want to support gets. So I'm going to trim some of this out right here. Do I need the logger? Probably. But in this case, let's get rid of the logger. And now what I'll do is I have a very simple example, and we'll just return some string right here. This buds for you. My apologies to Europeans with more respect for beer, but you get the idea. And now let's just go ahead and hit the F5 key. And so the whole idea is that when I'm just doing dev work, inside of my project, it's going to start up. It uses reflection to figure out what things you have inside there. And in the local debugger, I can now kind of get this. Let's go ahead and open up a browser and put that in right there. And then you can kind of see, there we have this thing working, and each time I execute this, and now the next question is, what code do we put inside there? But I just kind of wanted to do a quick walkthrough to kind of show you, how to get started. And now, and this is kind of like Julia Childs, who does a little something to a turkey and then pulls a fully baked turkey out of the oven. So the fully baked turkey for today's demo, is a function app project, which is called Dev Camp Demos. And so, here's a bunch of different Azure functions that we're going to look through using all kinds of different triggers. Okay, now let's go back here. One more thing is that if you've created an Azure function app and it's up in the Azure cloud, and then you're able to give Visual Studio your credentials so you can log in with your Azure subscription, you can use the publish command that can take your function app and just deploy it directly into some publicly accessible Azure website. You could also use a far more structured approach, where your function app gets pushed into a GitHub repo or Azure DevOps, and you can have a full CI/CD story with these as well. Okay, we're not going to get into those details, but you could be as casual and cowboy in your deployment, or very disciplined. Now, the next thing we're going to look at is calling the Power BI REST API. Now, the Power BI REST API, what is it? If you're coming to Power BI Dev Camp, it's likely that you know what it is and you've used it before. But it's an API based on open standards, such that developers can use any platform they want and write code to authenticate with the Power BI REST API and call API endpoints, to do all kinds of things, such as create a workspace, get data about workspaces. Now, it's secured by Azure AD. So whenever I call the Power BI REST API, I have to go through some type of authentication flow and get an access token. But once we get up to speed on this API, it allows me to do various programming tasks with Power BI things like workspaces, datasets, reports, dashboards. Now, any developer on any platform should be able to use the Power BI REST API. We have some great documentation. If you've never seen the documentation before, let's quickly go here, and I referenced that on the slide. But what you'll see is that there's just all kinds of operations and endpoints here, and this will tell you, basically how to get the URLs, how to package the parameters. But what's kind of nice is if you're using C# and .NET, you have a big advantage in that you can use the Power BI .NET SDK, because that abstracts away having to kind of worry about the low-level details of making requests and handling things like the access token. Now, what can you do with the Power BI REST API? So kind of thinking about this session, we can use it to retrieve data about our workspace inventory and what reports and what data sets do we have. We can also query and get data from the Power BI activity event log. We can create workspaces. You can add users and service principals, as workspace members. You can publish reports and data sets by importing PBX files. You're going to see, examples of updating connection details and data source credentials and embedding Power BI reports. Okay. I don't have an example of it here, but this would also be, in a pretty good scenario for creating Azure Functions that use the Power BI REST API to export Power BI reports and paginated reports, and put them in some kind of Azure storage so that first day of the month you can always have a PDF file available for the month close of the day before. Okay, now with the Power BI REST API, a couple details. One is we have to distinguish between the user APIs and the admin APIs. So for instance, there is a get groups async. And when I call that, I can basically get a set of workspaces, and I can call it as either a user, or as a service principal. But the idea is that you don't see a workspace, unless you are a member of that workspace. So it doesn't let you see things, that you haven't been made a member of. There's also the admin APIs. So for instance, we're going to look at one called get groups as admin async. And this provides users and service principals with this tenant level access, so you can see the details of every workspace. So the IT team, who's managing a Power BI environment, might look into, mastering the Power BI admin APIs, for some of the tasks that we're going to be doing. Now, just at a high level, our first step before we can call the Power BI REST API is to call to Azure AD, and we have to authenticate, and there's going to be some Azure AD application that we've created, and we're going to be able to get an access token. And then the idea is that when we call to the Power BI REST API, we're going to include that access token, and each time I get an access token, especially for service principals like we're going to be doing, it's good for an hour. So typically you get a service, you get an access token for service principal, and you do it once per execution, and probably we wouldn't worry about pooling service principal tokens, unless we really had a need to do that. But if you worked with the Power BI REST API, you've probably gone into Azure AD and created an application. Note that when you do that, there's an application ID. There is a tenant ID. You need to create a client secret. The other thing that you do once you create the Azure AD application, that creates a service principal in your local tenant. The Azure AD application, the service principal, it's a little bit can be confusing, but they're separate things. So the Azure AD application has an application ID, and it can be used across different Azure AD tenants. So to give a kind of a local tenant-specific representation, of the Azure AD application, we have what's called a service principal, and the service principal has an ID as well. But what you're able to do is you're able to add the Azure AD application into Azure AD groups. And over the next couple of slides, you'll see that this is an important part of configuring permissions. So what's important to note about service principals, and let's go back here. Let's go back to this application right here. If I go to application registrations and we open this up and we see app permissions, if we're authenticated as service principal, you never want to add anything here. This can get you in trouble. So ignore this, leave this blank. But you will have to create a app secret. And the app secret, or you could use an app certificate, which would be more secure, but you have to use one or the other. And the idea is that you'll get an access token that tells Power BI who you are. I'm service principal 1 or service principal 47. But the idea is that how does Power BI know whether you can access what you're trying to do? And it's all about configuration at 2 levels. One is the tenant admin settings we're going to look at over the next couple of slides. And also, if your service principal is given access to the Power BI APIs, which is just the user APIs, it can only see workspaces in which it has been made a member. Okay. Now, let's say that you wanted to have just the ability to use the user APIs. So you want your function app to be able to access a workspace and, add content. So the idea is you go up to the admin portal in Power BI and you configure developer settings, allow service principals to use Power BI APIs. You add the Azure AD group and you add your Azure AD app to those groups, and that's how you get access. And just to reiterate one more time, your code can only access workspaces in which, the service principal has been configured as a member. Now, there's also the admin APIs. So if I go, into the admin portal and I point to an Azure AD group for the allow service principal to use read-only admin APIs, and you can see my Azure AD group is called Power BI Admin Apps. Now, any service principal that I add in there will automatically be able to use the admin APIs, which means they can see every single workspace. There's this one issue I wanted to call out, and that is the user APIs give you certain information about a workspace. The admin APIs give you more, but you can't get the admin API detail for just one workspace. So you have to kind of configure a user or service principal with this all or nothing, permission. So we definitely have customers that have asked us for more granular support, and we're working on that. So I hope later this year we'll have something, where you can kind of have these admin level permissions, but at a lower granularity. Okay, now we're going to walk through 3 different ways to get an access token. Now, the very first way to get an access token is just to go through the client credentials flow, and you'll need to have a tenant ID, app ID, and an app secret. And what you can see here is that when you create an Azure Function project in Visual Studio, or in Visual Studio Code, it creates a local.settings.json file. So if you want to have, application settings that are available while you're doing your debugging, you're able to do this. Note that, let's go back here. Let's go back to my Azure Function app. And if I go down here, to configuration, note that, here in your Function app, you have these settings. And so, you can have one set of settings for production here, while locally, while you're doing your testing, you can use another set of settings. But if we look at this code, now what we're going to do is we're just going to use, the Microsoft authentication library technique for doing client credential flow, which means getting an app-only access token. So we use the confidential client app builder. If I just point out a couple things about this, note that when you get an access token, you have to provide a scope, which is one or more permissions. And I told you that we don't use permissions for service principal, but yet you have to pass at least one permission. And so we just basically pass the .default. And basically this means we get an access token that tells Power BI who we are, but not what we can do. Power BI knows, what you can do by looking at, how tenant level configuration, is set. Okay, now the next thing we want to look at, let's say that I decide that it's not secure enough, for me to, just have my app secret, inside of configuration. So we'll go to, we'll create a Azure Key Vault, and then we have secrets inside here. So there's a way for you to either import secrets or to create secrets. And if you have your app secret here and you rotate it, you can just make the change in one place. So it works pretty well. Now, the other thing we have to do, let's say we've created this Azure Key Vault and we've added some secrets to it. Our code in the Function app needs to be able to get to those secrets. So the way that we do that is by configuring what's called a managed identity for your Function app. Now, if I go back here and I go down a little bit, what you'll see is that there is a identity tab, at this point. And, once I get to the identity tab, that's the wrong place. Okay, I need to go to the Function app. Okay, once I get to the function app, now we go to identity. So what you'll see in a new function app is there's no system assigned identity. So you turn it on, and it automatically assigns a GUID. And kind of a little secret is that this is automatically recognized now as a service principal. Now, with Azure Key Vault, kind of the new modern way to do it is to use Azure role assignments. So what you're able to do, is you're able to, give this managed identity access and what particular role, Key Vault secret user, and so, once we have this, we have the permissions that we need. Now, once you've seen that and you've got these permissions, the idea is that we can now, and let's kind of, step down this code. The first thing we want to do is we want to create kind of a secure connection. So if you look at these first 3 lines, we're going to create what's called a default Azure credential. And this kind of makes it easy if you're using managed identity. What's the thing that we want to access? So there is the Key Vault URL. And then, we have the Key Vault secret client. So this is just kind of the class that allows you to extract secrets. And the idea is it connects, it sees that what your managed identity is, it sees that your managed identity has, permissions, so now we're able to kind of, read the different secrets through here. Okay, and then go ahead and get an access token just like before. Okay, one more thing, and this is really neat, and that is, let's say you don't want to create an Azure AD application. You just want to use a managed identity just to go, right to Azure AD, and basically get a an access token. So once you have a managed identity, let's go back over here. And so what I want to show this time is if I go into groups, and then I go into my, Power BI apps, and I go to members, and that is one Power BI apps. Okay, and I look at members. What you can see is that, you can add a managed identity, and then all of a sudden, this managed identity will automatically have, permissions to go ahead and, get workspaces that, it is a member of. One other thing to note is that, let's say I go to Power BI, let's say that now I go to some particular workspace, and then we go to access. What you can see here is, let me go ahead and remove this. And now I want to add it in. So when you have a managed identity, you can see that you can add it in. I can add it in as an admin. I can add it in as a contributor. Great. That works fine. The one thing that we have to fix on our side is if I come back here, it then switches over to the GUID. It doesn't, elegantly display the name of that managed identity yet. However, if we look at the code that we showed last time, get the app ID, get the app secret, get the tenant, and now look at this code. It's just give me a managed identity credential, and what is the scope of the access token that I want? And this is automatically going to give you back an access token. And once again, as long as you're, the service principal behind your managed identity is configured with Power BI Access, you're good to go. Okay. Now, next thing we want to look at here is in my in my demo. Let's say we come back here, and I have these functions. I put all the code that codes against Power BI, in the Power BI Manager, and so now, I can just kind of switch back and forth, between one of these approaches and another. The one nice thing about using local credentials, is that it works, in Visual Studio. The one last thing about, get access token with managed identity is, I haven't figured it out how to make that work in Visual Studio. So I just kind of use one of the first two. And the idea here is that, as you start the application, any of these things that we're going to call, are going to automatically, call into the Power BI REST API. Let's go ahead, kind of do our first demo right here. And as this thing starts up, You can see with all these APIs that we've created here, after a second, it kind of brings up a console and it says, if I want to call, HTTP get workspaces, I'm going to grab that and I'm going to call. And, what we can see here is it just kind of returns, data on the two workspaces, in which my service principal, is a member. We've got a second one here, which is get workspaces as admin. And then one more, which is, get workspaces as admin with expand. We're going to see this one in just a second, but let's say I go back here, but now you can see, it's very easy for us to kind of call in and start debugging these things. And now that we've done that, let's go back here. So once again, here's an example of what's in the Power BI Manager class. Get workspaces just uses the user API, and it returns back just the workspaces that caller is a member of. And then as long as you have admin API access, you're able to call get groups as admin async. Note that when you call get groups as admin, my puny little tenant only has 20 workspaces. But if you're in a tenant that has 5,000 workspaces, you're not going to be able to make a simple call and get back all of them. So get groups as admin, has lots of different parameters. So you can go through and, take smaller chunks, maybe one workspace at a particular time. Note that you can also call expand. So what's kind of neat about making this call right here is that it gives you back information about all your workspaces, including, the data sets, the reports, and the users, that are inside. Okay, now moving along. Sorry, we have to move at a pretty fast clip, but I've got two more important demos I need to show. The next demo is inspired by one of my teammates on the Power BI CAT team, Rui Romano, who, a while back created a community effort called the PBI Monitor. Now, his uses Azure Functions with PowerShell. So much of what I did for this demo was just to kind of follow what he did and just kind of put it in C#. But the idea is that, first of all, we need a storage account. And when you create a storage account, you create containers, and that's where your files are going to go. Now, there's also access keys. So, as you create your storage account, your applications and Power BI Desktop, are different parties that need to access the files in there, whether they're, reading and writing in the case of the Azure Function, or just reading in the case of Power BI Desktop. So you're able to get the key, which is, just kind of the password. That's what I would use if I need to connect Power BI Desktop to, one or more files in Azure Storage. There's also the connection string, and the connection string includes things like the account name, and its URL, things like that. What you'll see here. Let me go back over here, and what I want to do is I'm going to go to GitHub. I'm going to go to Azure Functions for Power BI, and I'm going to go to the DevCamps demo. And what you'll see is that there's a local.json file. So here's just kind of an example of, some of the configuration information, that you're able to add inside there. And so, one of the things that you could do is, add your storage key inside there. So some demos I'm going to have the Azure, web job storage, which take the whole connection string. And then there's a case where you're talking to the Power BI REST API and you're setting credentials, for an Azure storage account, so you might need the key as well. Okay, now at a high level, here's what the demo is going to do. It's going to call to the Power BI REST API. And so I have these two Azure functions that fire once a day, 6 in the morning. And the idea is that we have an Azure storage account. And so every morning at 6 o'clock, we fire this Azure function on a schedule, and it calls the Power BI REST API and does a, get groups as admin and does all the expand. So then I have a lot of data inside there. I also generate an activity log JSON file for today's activity. Okay, now the idea is this is data that it's very hard for Power BI Desktop to get to. However, if I decide that once a day is good enough, or I could rerun it, once an hour, I can basically keep updating files, and then I can create a Power BI Desktop solution that pulls that data down and reports on it. Now, here's an example of a Azure function. And what you can see is that we're going to create a new file called PBI data/workspaces.json. Now, what happens there is that I'm just going to call to, expand workspaces. Likewise, here we're able to, this code right here is extracting activity from the Power BI activity log. And then this file has to create the file name on the fly. So earlier, I kind of used a blob binding to create a new file in Azure Storage, but I knew the file name. So here's a case where we're going to create an activity file, and we're going to put today's date into the file name. So I can't use a binding, but this kind of code shows, how you could do the equivalent, with the blob container client. Here's some activity, event activity extraction code. I think I'm going to step through this. This is great code, but it's complicated, and I think there's more stuff I need to get to. So I'll just kind of leave it as an exercise to the reader to kind of go through and digest, how this code is working. But the idea is that now we can create something in Power BI, that kind of shows us our inventory of workspaces. If we go back here to Power BI, and let's say, I go back to home, and now we open up our tenant monitor, and then we see that, what do we have in this particular workspace? We can drill through inside there. So you want to list data sets, reports. You can go further than this, like Ruby does in PBI Monitor, and look at things like data sources. Okay. Or maybe we want to look at activities. What we can do here is we're able to, make this so it's pulling all these files down. And just for good measure, what you can see here, if I go back to the tenant monitor data set, and we go back to settings, we've kind of got things set up here so that we can set data source credentials. Here's where you'd have to kind of put that account key to configure it here, or the same thing in Power BI Desktop. But now I can refresh it on a schedule or refresh it with code. Okay. And now you've seen that. Let's keep moving. So, got about 15 minutes left. I think that's just about enough time to get through these two last sections. The next thing we're going to look at is a scenario where we have, let's say we have some kind of a system that's able to get sales data based on some filtering, and basically, spit it out into some CSV file format. So I've got all these different CSV files. They all have the exact same column layout, but yet I need a separate data set and report for each one. So here's the way it's going to work. We're going to create an Azure function that monitors Azure storage in a particular container. And every time someone adds a new file there, we're going to make the assumption that no one's going to add, a file that doesn't have the correct data layout. But the idea is that when someone uploads that file, it's going to trigger my function to run. And that function is going to be able to see that file. And so what it's going to be able to do is it's going to use a template. It's going to be able to take this file name and take a PBX template, upload it, give it the right name, but then by updating parameters, we're going to basically point it back to that and then do a refresh. And the idea is that we can automate things such that, tomorrow when someone uploads another one, the process kicks in, automatically creates, a new workspace, a new data set and report, and layers it back. Okay, so now you kind of seen the concept. Let's kind of see how everything gets, put together. So what we have here, is a sales report template. Now, the other thing I'm going to do in this demo is I'm going to use this third-party tool that I've used for a while, which is the Cloudberry Explorer. because this allows me to connect, to my storage account. And now here, you can see that we have this, sales report template. Now, when my function runs, because someone's uploaded a CSV file, I'm going to need this PBX file because it's my template file. So what you can see here is, that we're able to kind of add that in. One other little note is, notice I don't have connection here. And if you don't have a connection, the way things work here, once again, is that if you have a app setting called Azure Web Jobs Storage, and then you have your connection string inside there, it will automatically look to that, by default. So it kind of extracts the storage account away from your code. You can also see that here, I want access to that file as a stream. And so now what's going to happen is that I'm going to call process file upload. And I'm going to pass it the workspace ID. We're going to need the template, so we pass a stream. And then also we're going to need to know kind of the file name inside there. Now let's see if we can kind of get this working. So if I run this right here, I've also got things set up so that my blob trigger will actually trigger in Azure, when I have the thing running here, inside of the debugger. Now, let's go back here. And so this time, where are the files going? They're going up into sales data. And the idea is, actually, let's do this. Let's go ahead and delete all these. Now that I've done that, let's go and we'll go back to Power BI. And this time we're going to go to the sales workspace. And I'm just going to go ahead and delete these. As I created these in my last test, I should be able to, create them again, in this test right here. Okay, so, what is the, desired effect? The desired effect is, got to get all these things pieced together at one time, is that I want to be able to copy, these files, up into that. Oh, give me one second. I did that incorrectly. Okay, I want to copy these files, up into that Azure store and see kind of the code react to it. So here we'll go ahead and we'll add, Texas 2018. And we'll add, West Coast. And, as we're doing this right here, what we can see is that things are executing behind the scenes. Once it's done, I should be able to come back, over here and truly see, hey, for each one of these, there's, Texas 2018, great. There's the West Coast in, 2019. And the idea is that, as files get ready, we're just going to take them and we're going to dump them in here. And then, as we do this, we're basically just going to let, what's happening behind there, take that file and process it, as it needs to inside. And, each time it goes back, there's 2020, let's open it up, things are working. Okay, so let's take a quick walk through, that code. So what you saw here is that when it reaches the Azure function, the Azure function has fired, because it's responding to this file, and then it calls process file upload. So this is in the Power BI Manager class. Okay, you kind of seen the report there. One thing to note about the report before we step through the code is that the report, is built using dataset parameters. And the idea is when you define dataset parameters, inside your project, then as you write your queries, and you might have to, deal with the M code directly, you can get rid of any hard-coded path, to an Azure storage account, a container, or a file. And you're just, able to, add those things in. And what's nice about this is that these parameters are easy to change. So what you can see here is that when we process the file upload, well, we have the file name, but now we need to create the import name. So let's just kind of take the CSV off the end. The idea here is the import name is what shows up here, as the name of the report and the data set, as we see it. Now, next thing, we publish the PBX file. We'll see this function in just a second, but now let's update the parameters, and you can kind of see that, what are we changing? The CS file name. I could change the container name, or I could change the, the storage account name, but it's the same. So you change what you need, and then you call update parameters in group. Okay. Two methods that we haven't seen yet: publish PBX and patch blob storage credentials. We'll see those. But just finishing off here, after we patch credentials, the next thing we do is we want to refresh, to make sure that we have an imported mode data set, and we point it to the specific file, that it has, and then we go ahead and run credentials for that. Okay, just a quick look. Here is the publish PBX file. Note that it has the long method name, imports.postimport with file async in group. Notice that that method is asynchronous. So when it returns, you don't have a guarantee that the job is over. So, here's kind of the typical example of creating some kind of a loop where you're looking at import state. And when you see the import state has succeeded, it is then complete. Also, here is the code that we're going to use to, set credentials programmatically, And so what you can see here is that, here's where I need the blob storage key, as part of my configuration, just so I can go ahead and use the Power BI REST API, to patch credentials. And then after that, I should be able to run a successful refresh operation. Okay, that was a lot of stuff. So we got one more section here. And in this last section, what we're going to do, is we're going to kind of take heed to the fact that if I come back here, as I create a particular Azure function, that uses the, the HTTP trigger, it gives me just a, simple way, to be able to go there, and be able to call that and get the data back. So what now we're going to do is we're going to look into, I think I've gone back too many slides. Okay. Last section here. So what we're going to look at now, is this simple proof of concept application. So I created it with React and Material UI and with TypeScript, and it just kind of does the hello world to show you how to make calls to 3 different Azure functions. So once again, all this is part of the sample code that you're able to get. But if I go back here to Azure Function SPA. So once again, I just have a simple application. You can kind of see here that, it's written. If you haven't used React yet, it's great stuff. But I have, components right here. Now here, if I look at app settings, so there's 2 projects here. One is my project for my Azure Function app. The other is for the SPA. So when I'm using the SPA, I might just want to do live debugging, right against the, the other side. So that's what I'll do here. But notice that, I could also, when it's time to go live, switch so that I'm pointing to, the Azure websites site. Okay, now what I'm going to do here is look at some of the components right here. So let's go ahead and start it up. And, as I start it up, I'm also going to start my little friend Fiddler. And the idea is this, with this application, what you're able to do, is make a call in your application to get data back. So maybe I want to track what workspaces this user has, or I want my function to be able to allow the user to create a new workspace or upload a template PBX file and do all kinds of things. If I come back here, what you can see is that, from the perspective of, my client application, it just called get app workspaces, and it got back data. Over in the back end, one nice thing about running these locally is you can see all the direct calls that your function app is making to the back end. So let's say that now I go to admin workspaces, and I want to get that data back. What you can see here is that when you call this inside here, and now we can kind of get a lot of deep knowledge, of what we're looking at inside. Okay. And then, the one last thing I wanted to kind of show here, is the embedded report. So I do a lot of work with customers that use app owns data embedding, in which, Power BI doesn't know who the user is. So we use a service principal to create an embed token, and send that back. And so, here is a simple example where, the client front end doesn't really need to know very much. It just needs to, know how to call, and basically get the embedding view model. It gets back the embed token, the embed URL, and the report ID. And, if you take a look at this application, what you'll see is that we have components and kind of a simple React application with routing, but then we have services, which is basically just a little TypeScript class I made. But what's kind of really neat is that you can kind of model out the data that's coming back. So, if you know what things look like, when they're coming across the wire, such as, here's a tougher one, when you're calling, get workspaces with expand, what shape does that data have? So it's possible for you, to kind of define things like the admin workspace, define things inside here. And what that makes it possible to do is now to kind of strongly type the return values that you have. Okay, now, a couple more points about this. That is, let's say that I come here and, now I go ahead and cancel out that. And what you can kind of see here is, you just basically get strongly typed data back in your TypeScript application, from the services that you had. Now, one issue that you have to deal with is something which is called cores. So by default, if your application, is running out of one domain, it can't automatically make web API calls, into a web service served out of another domain. But over the last few years, we've basically gotten around that by creating something called cores, cross-origin resource sharing. And, in different places at the beginning, it was really hard because you had to implement it all yourself. The web API that Microsoft has kind of made it largely transparent. But now what you can do is note that by default, your function app won't support cores at all. And the idea is that then you can't use it, inside of browser-based applications. So what we're able to do here, okay, I know I'm jumping around a lot right here, but what I want to do is I want to go back to the Azure portal. Back in the Azure portal, let's go back to our function app one more time. And what you'll see is if we go down far enough, we have cores. And the idea of cores is you can put origins. So I just kind of said, it's a demo. Let's just go ahead and do star. Which means you could come from any domain, and it can use cores to call across boundaries. In a more secure circumstance, you might just want to whitelist the URLs that client applications are being built at. If I come back here, and I just want to kind of point out that if you want to use cores, while you're testing in Visual Studio, the way to do that is just to put host cores star, at the bottom of your local settings.json file. Okay, now we showed you the embedding demo, and now we're kind of on the last content slide, which isn't really a content slide, but more of a slide saying if I had another hour, here's what I would go into. So everything about my demo that I did, the function app had to make a secure connection and call to Power BI, but I've kind of have all the functions just kind of set up allowing anonymous access. So for testing, that's great for me to give you a proof of concept. But Azure Functions have lots of options to put security. You can have function level access codes that kind of get put on as a query string parameter. You can create admin or global level access codes. You can also go to a function app and basically configure authentication for you. Add identity provider. So you can basically do anything with a function app that you would do with an Azure AD application. Allowing making users log in using any type of flow that you want, which is supported by Azure AD. Okay, so now we've gotten to the end here, and a couple questions that we have, and I guess I really didn't take time to take questions as we went, but I think there are a couple here. So one question is, why can't we use managed identity to access the Power API directly? And I think you must have asked that during demo 2, because when we got to demo 3, we did access the Power BI API directly. Okay, it just matters if people want to use an Azure AD application or not. So not every company's accepting of managed identities at this point. Okay, back on the PBI monitor thing, what's the cadence, of workspace reports usage that telemetry is updating? Is it fast enough to do mashups? Well, I'd say at a high level, when you query the Power BI activity log, it's you're getting data that's up to 15, sometimes 20 minutes old. So it's not real time. And also, if you've never worked with the the API for extracting things, there's all these rules, such as your extraction window cannot span a 24-hour workday. There's so many times that you can call it per hour. So, once again, it's something where you just have to, get the documentation and learn how to work with the Power BI REST API. Okay. Dan, did you want to take over and make some comments?
Sure. I think there was one more question from Moof. Did you get that one? Is it possible to use functions to access the Power BI data model and extract data?
Okay. Is it possible to use functions to access the Power BI data model and extract data? And the answer is absolutely. So I guess what I'll do, well, there is a dataset execute queries API. So if you can put together a DAX query, using DAX Studio or something like that, there is an API, which is part of a REST API. Used to only be part of Tom, now it's part of the REST API as well. But it's execute, query and group, something to that effect. And the idea is that you execute it, you pass a DAX query, and it returns a JSON result. So I think that answers that question. And then you get your data back as JSON. You do whatever you want with it. If you want to put it to a CSV file format or just save it as JSON, that's up to you.
Thanks for telling us all about and teaching us about how to write Azure Functions to call the Power BI REST API. I wanted to just call attention to a couple sites before we head out. So we have a Power BI community at community.powerbi.com. Make sure to check that out for all the tips and tricks and resources and things like that, as well as past DevCamp recordings. You can visit there and get connected with the Power BI community. In addition, we have all the past DevCamp sessions available in the webinars and video galleries, and you can drop down and filter it by view, and then you could catch all the past sessions from Ted. I wanted to thank you so much, Ted. I want to wish everyone a happy 4th of July if you're in the United States, and thanks again, Ted, and we will see you next month.
Thank you. Goodbye, campers. Next month, we have Scott Sewell talking about creating Dynamics 365 solutions with Azure Synapse Link. Going to be a great session. See you then.